Okay, let us solve another example. So as you have noticed in our previous examples, we have simply uh, short instruction, solve. Okay, something like this. No? You're asked to solve, and then you're given the equation. But sometimes the problems will really give you details of what you need to do. Like for example, for this fourth example, we have find the solution of the differential equation that satisfies the given initial condition. So we have here, we are given the differential equation, and we have something like this. So this is what is meant by initial condition. We have y sub 1, y of 1 is equal to negative 1. So you need to understand this. So you have two problems now. One problem is to solve this, and then to understand what does it mean. So from algebra, so part of our solution is to explain this one. From algebra, we have y as a function of x, right? So therefore, we can say that this is just the given here. This is the value for x, and this is our y. Okay, so take note on this. You should not interchange these two values. This is a very critical values in order for you to get the right answer. Okay, so once again, if you have tried solving this problem using the many methods, but you failed to get the solution of this differential equation, then it's time to test whether the given differential equation is Bernoulli's equation. If you look at the given, it's really very far from Bernoulli's equation, because the Bernoulli's equation is given in this form: y to the, or y prime plus p of x times y equal to q of x times y to the n, right? So it's very different. And let's see if we can manipulate the given differential equation. Like if you're going to divide both sides, because this one can be written as, okay, let's rewrite this given: x times y prime plus y equal to y squared. Now if we try to mimic this equation by dividing both sides of this given differential equation by x. Okay, so if we divide this by x, divide this by x, divide this by x. So the x here at the numerator cancels out with this x at the denominator. So we have now y prime plus, we can rewrite this as 1 over x times y equal to, this can also be written as 1 over x times y to the second power. Okay? So if you look at this given now and compare it with the standard form of Bernoulli's equation, we can say that this really looks like the Bernoulli's equation, right? Because this is our p of x, this is our q of x. Okay, so let's get our p of x, which is from this resulting equation. This is equal to 1 over x. Okay, so this is our p of x. And then our q of x is, this is our q of x, which is equal to 1 over x. And our n is simply the exponent of this, which is equal to 2. Okay, so we can use the formula because we now determined that this is a Bernoulli equation. We can use the formula, but before that we have to solve first the integrating factor. Okay, so the integrating factor factor is given by this equation. I of x equal to e to the integral of the quantity 1 minus n times p of x dx. Okay, so substituting e to the integral of 1 minus n, where our n is equal to 2. Okay, so 1 minus 2, then times our p of x is 1 over x, then multiplied by dx, which is equal to 1 minus 2 is negative 1. So e to the negative 1 integral, then dx over x. Or we can write this as e to the, put the negative 1 outside the integral, then we have integral of dx over x, which is equal to e to the ln x. Then we have negative 1 here. Okay, we have negative 1. So again, we can put this as the exponent of this one. So we can rewrite this as e to the ln of x to the minus 1. So be careful in this, because without knowing how to do or manage this one, then you will get the wrong answer. Okay, so rewriting it here, we have e to the ln of x to the minus 1. Then from the properties of logarithm in our algebra, so we can write this as x to the minus 1 times ln e, where ln a is equal to 1. So therefore, our integrating factor is equal to x to the minus 1. Okay, this is our integrating factor I of x. So substituting this in our general form of the general solution of this Bernoulli equation, or Bernoulli's equation, which is given. So we can abbreviate this as general solution. So the general solution is given by this equation: y to the power 1 minus n equal to 1 over the integrating factor multiplied by the integral of the quantity 1 minus n multiplied by q of x, then multiplied by I of x, then multiplied by dx, then plus c. Okay, substituting, we have y to the power 1 minus our n is equal to 2 equal to 1 over our I of x is x to the minus 1, and times 1 minus 2, q of x is equal to 1 over x, then our ix is equal to x to the minus 1, then times dx, then plus c. Then again, from the laws of exponents, we have x to the minus m equal to 1 over x to the positive m, or vice versa. If you're given 1 over x to the minus m, you can write this also as x to the positive m. So we'll apply this one here. So y to the 1 minus 2 is y to the power negative 1 equal to, we can write this as x to the power 1, or no need to write the power positive 1. And this is, we still have here the integral. Now we still have to integrate that one. So the integral of, we have negative 1, then multiplied by, we can bring this down, then we have 1 over x to the power 2. Okay, it's either you bring this down or you can also bring that up. It's up to you, which is more convenient for you to manage the integral of this. So this is x to the power 1, no need to write the power, times, you put the 1 outside integral sign, and then you can raise that up. You can make like this, dx plus c. So I think it's easier to handle this because we can just use the power formula. Okay, so we have to use this integral of u to the n dx is equal to u to the n plus 1 over n plus 1 plus c. Okay, so we have to make use that formula. So y to the power 1 is same as 1 over y to the power 1, so no need to write the power 1, equal to x times the integral of, okay, so we have here negative. The integral of this is simply x to the minus 1, because when you add it by 1 and divided by negative 2 plus 1, that is negative 1, then plus c. So 1 over y equal to, so negative, negative, so it becomes positive. So x times, we can rewrite this as 1 over x, because from the law of exponent using this, okay, so we can rewrite this x to the minus 1 as 1 over x, then plus c. Or if you distribute this, we have 1 over y equal to, so x over x plus c x, or 1 over y equal to 1 plus c times x. But we are given the initial condition. Okay, so we have here the initial condition. So substituting, so y over our y is equal to negative 1. Okay, so this is negative 1 equal to 1 plus c times x, x is equal to 1. So this is negative 1 equal to 1 plus c. So transpose this. So this is minus 1 equal to c, or minus 2 equal to c. Alright, so substituting this, okay, substitute this in our equation here. Okay, let's take this equation. Okay, so let's rewrite it here. So 1 over y equal to 1 plus c times x, and our c is equal to 2. So 1 plus c times 2, okay, or c2 or 2c. So 1 over y equal to 1 plus 2c. Sorry, c is 2, so this should be x. Okay, sorry, let's do it again. So we have 1 over y equal to 1 plus our c is equal to 2, then times x. This is our, but our c is minus 2, so this should be minus 2. So 1 over y equal to 1 minus 2x. So solving for y, so you either multiply both sides by y, so multiply this by y, so you have y cancels out, so 1 to 1 minus 2x times y. So dividing both sides by 2, okay, divide this by 1 minus 2x. So 1 minus 2x, y divide this by 1 minus 2x. So cancels out, so 1 over 1 minus 2x equal to y. Or y is equal to 1 over 1 minus 2x. So this is our final answer. Anyway, if your exam is a multiple choice, then perhaps this could be your answer already, this one here, before you multiply by y both sides. So if you cannot manage, no, that's very difficult. If you can manage to rewrite your result into some other form, so perhaps you might not be able to choose the correct answer if your exam is a multiple choice. So be careful. So that is only algebra. Okay, so that's all. Thank you. And if you have any questions, you may leave your questions or your message in the comment section below. Thank you.